Was it Zoom?
All right. So today I'm going to talk about a little bit more sort of under the covers on Python. And you probably read the description on the website or in the conference guidebook that you get to a certain point in your Python programming where you're pretty smart, you figured out how to use Python, you've used it for several months or maybe like 1 or 2 years now, and you think you understand it pretty well, you know the syntax pretty well, you've done all these kind of things with it, but sometimes you run into these issues that you don't have time to debug, where Python doesn't act the way you think it should, and you're perfectly convinced that your program is, your code is absolutely correct, but Python still doesn't behave in the way that you think it should. So hopefully some of the information I have today for you will help to sort of explain those things, to give you more of an idea of how things work under the covers. All right, so that's the main goal. So if you haven't been to any of my talks yet, and EuroPython, it's a little bit of background about me. I've been programming Python for a while, but there's a lot of information to read here. So in all my talks, I just say, don't read this because it's too confusing. The most important things to know about me are that I like to teach, especially Python. So I teach at companies, I teach at conferences. I write, so I'm one of those weird programmers that actually likes to write. So I have like 1 or 2 books out there. You may have seen them already. But the most important thing about me is that I'm a software engineer. So I code and I've done all kinds of crazy things with Python. And if you're curious about how I got started, I was on the original Yahoo Mail engineering team where we built most of it with Python 14 years ago when no one ever heard of Python before, so it was quite interesting. The back-end mail store was C++, but all of the middleware, front-end, and the main application, that was all Python. So that was my first experience with Python many years ago. So anyway, so about this talk and about you guys, so there's going to be like sort of four main parts. The first part is sort of like not as related to the rest of the talk. So it's sort of introduction for people, for people who are getting here after the beginning. But it's sort of like a bonus material, all right? So that's the thing about the first part. So I'm going to talk about special methods to make your classes act like Python data types that you're used to using. So after that sort of bonus section, then we get to the real reason why you're here, okay? So again, about you guys, you have some Python experience, you still don't understand group behavior, things that you can't explain well, and you want to learn more of the internal stuff. Okay, so that's sort of like the main reason why I made this talk. Of course, when I made this talk originally, when I did the proposal for this talk, I said, oh, you know what? I think I only have half an hour of material. Maybe I can stretch it to 45 minutes. And then the program committee assigned me to a 90-minute talk. So I had to graft an entire half of this talk together. So halfway through this talk, I have to go and make some new slides. Okay, so you'll see that. Okay, so let's talk about special methods first. So this is the bonus part. So if you come in late and you kind of skip this part, it's kind of okay. All right, but it's kind of fun because I like showing people how to make their objects act like Python types because it's a very fun thing to do. All right, so since you guys already know some Python, then you already know how to create a class, right? So here's just an example of a very simple class where I'm creating an address book entry, okay? Right here. Is there a way to put the lines for the front part to see it better? Okay, that'd be great. That's okay. So yeah, this is a very basic class, so that it's easy to read, right? Here we go. Okay, so there's a constructor or initializer. We don't say constructor in Python because we know Python manages memory for us, so it's an initializer. Python constructs our object for us. And after it makes the object, it calls under init as the very first method to pre-process it, and then Python gives the object back to you. So that's why we call it an initializer instead of a constructor. Okay? So you can see it takes 2 parameters, name and phone number. There is a third, of course, which is the required self argument. A lot of people complain that, why do I have to type in self all the time? Well, it's because we don't wants it that way. Okay? To be more explicit. And that's very important. You know where things come from, where things are going, because you can see self.name. If this was not required, and you all of a sudden saw self.name, you go, where did it come from, right? So anyway, so when you, okay, so it's a you scratch my back, I scratch your back kind of thing. I know there's probably some way to say that in Italian. I just don't know what it is, right? But since you went out of your way to put in self as the first argument, when you call methods, you don't have to explicitly pass it in, okay? So you did something that's for Python, and Python will do something that's for you, all right? So when we create instances of this address book entry type, we only have to pass the name and the phone number, and then we have a method here to update the phone number, so you just pass the new phone number and then get the sign. So this is a very basic class that you can pretty much understand. And you can also see I also have a static class member too, all right? Everybody know what a static class member is? It's an attribute that is shared amongst all instances. All right, so once you make a change to this class attribute, all of the instances are going to see that new version number if you were to upgrade that. Okay. All right, so that's the important stuff. Okay. All right, so let's take a temporary sidetrack here. So how many of you have a computer science background? Yeah? Okay, that's most people, right? So when I say something like call by reference or call by value, that makes sense to you, right? So that's a very easy question for people to ask when they're learning the language. So is Python call by reference or call by value? The problem is this type of thinking doesn't really apply to Python. Okay? You can think that you can say that it's neither, because it doesn't obey these two rules. But you can also say that it's both, because depending on the type of object, it may do one thing for certain types of objects, but it'll do something else for other types of objects. Okay? So we already know that Python objects are always passed by reference, always, right? That's just the way the rules are. Okay? The thing is, though, that if you have a mutable object, okay, aliases act like pointers. It really, when you make a change in that function, the caller, the data structure will see that change, right? So in that sense, it's like call by reference. But if you pass in an immutable object, like a string or a number, and the function changes that variable, well, because it's immutable, it really just gets redirected and points to another object, right? So it's like call by value, because that change is not reflected in the call, okay? So that's why Python is both in this case, but it's really neither, because it doesn't kind of adhere to that. But you know that in reality, that everything is a call by value of the reference, all right? Really, right? Because it's a pointer, the number, that number doesn't change because it's immutable, but it is a reference, right? So, anyway, so whenever your friends are learning Python, they ask you the same question. Now you can give them this direct answer. In Python, it's more important to talk about the mutability of an object than it is talking about calling convention. Okay? All right. So that's enough of the side. Just keep that in mind. I had to add this extra stuff in there because people ask all the time, right? You have to have it clear in your head. Okay? Nobody explained this to me when I was learning Python. It would have been nice. All right. Okay, let's go back to our class. So let's create some instances. So we know that when you create an instance, you call the class as if it was a function. There's no new keyword like there is in like Java or C++. And you pass in the name and phone number. Okay, that's fine. Now we can call those attributes, those instance attributes that we defined earlier. Okay, because now we have self, which is our instance. Now we can call them directly by name. Okay, so that's great. Now, one thing that makes Python different from other object-oriented programming languages is that you can have dynamic instance attributes. So immediately, I can just create something from scratch. It's completely different. That was not in any of the code back here. Okay, so this tattoo did not show up anywhere. But now instantly, I can give John a tattoo, but Jane doesn't have one. Right? So it's completely different. All right. So we know that address book entry version is a class attribute. It's one of those static class members, right? We'll just talk about that. Yeah, sure. Look, we can use our instance to get access to it. Okay, that's great. The thing is, though, I still would prefer you to use address book entry.version instead of calling it through the instance, because I want you to always think that that is a class member. not an instance member. The only reason why you have this is that this is sort of a courtesy lookup, because if I don't have it, I want to check if the class that I was instantiated don't pass it. So it's one of those things that Python gives you as a polite bonus, all right? But what happens when I do this, which you cannot see? Okay? All right, because you can't see it, it actually says John.version equals 1.0. What happens in that case? Did I change my class one? No, you didn't. You created a new tattoo. Okay, so if I do print John.version, yes, I will get 1.0 now. But if I print Jane.version, she is still looking at the class one, not the instance dynamic attribute that I just made. Okay, this is the source of a lot of bugs. When you're using the instance to refer to a static class member and you assign to it, you're really not assigning to it. What you're really doing is creating a local variable, and you are hiding access to the global one, to this global one. Okay, so it's like you remove this thing from your scope. You can't get access to this one unless, of course, you go back and use address book entry .version like I originally suggested. Then you wouldn't have this problem, and you wouldn't have an unexplained bug in your code. Okay. Everybody understand that? Okay. Very important. This catches a lot of beginners as well. So my job is to create more bug-free Python programmers. Okay, that's you guys. All right. Okay, good. So what's really funny, and I would do it if I had the whiteboard here. So if I had the whiteboard here, I would say, if you did this, it would actually work. If you did like print John.version, print John.version. And then I did John.version equals 1.0, and then I did print John.version again. And so I would output the 1.0, but if right after that output I did del of John.version, and then print John.version, I actually won't get an error. I'll actually get this again, because now I removed the local variable. I did a del on it, del John.version. I got rid of the dynamic instance attribute. So now when I do print John.version, now it's going to go, oh, I don't have one, so I'm going to go with the class one. So now you're getting back to the 0.1. So it looks really weird to see code that says print John.version, del John.version, and then print John.version right after that and have it still work. Right? It just looks very odd. But that's what you're doing. You're removing that local reference, the dynamic instance attribute. Okay? Everybody got it? Okay, good. Question?
Sorry, what if I do perform a delete again on the instance? What happens?
Okay, so what if the question is, what if I perform a delete on the instance? Well, if I delete the entire instance, then...
sorry, the delete of the attribute again.
Oh, if you delete the attribute again, you should... Okay, so the question is, what if I do another del John.version? What do I get out of that? That's a very good question. And I actually haven't tried that yet, but my guess is that you would actually get sort of a local error. Do you get an exception? Okay, so this gentleman here says you would get an exception. So I agree with that because you're trying to remove something that is not there. Okay. All right, good. Actually try it if you have your laptop. There's nothing like seeing the source code be the source of all truth, right? So, all right. So let's talk about a subclass now. So we all know how to create subclasses. Subclasses inherit everything from the base of parent class, and you can customize it by tweaking it a little bit to make it different from the class that you inherited from, right? So one thing you have to keep in mind is that if you override any of the methods, like the initializer, it doesn't call the base class one. So if you really want to call the parent class under init, you have to do it explicitly, like I did here. Okay, so this is employer address book entry, which is a subclass of address book entry. So I'm going to have two more information, like employee ID, and in America we use social security number to identify ourselves to the government. Okay, so so this one is slightly different from the address book entry because I have two new pieces of data. Now, what you could do, instead of doing this, I could have just copied the code. I could have just copied the self.name equals name, self.phone equals phone. Okay? But what if your original initializer was more complicated? Right? What if it was a big block of code? Now I'm going to cut and paste that into my subclass, Well, that's not good practice, right? Because what if you had a bug in that original one? Now you've got that bug in 2 places. Okay, so you really don't want to cut and paste code from your base classes. Okay? You really want to just call the parent class version of that to set it up. And then you can do your own class customization afterwards to do the, the special stuff for this particular class, right? Right? Everybody understand that? Don't cut and paste code. It's really bad. Okay? So the way you do that is you actually call the initializer for the base class explicitly like this. Now the only catch is that if you have studied Python and you learned it pretty well, you understand that Python has a concept of bound versus unbound methods. Okay? And the difference is, when it's unbound, it means you just have the class and you have a method. You don't have any instances. Okay? As soon as you make an instance of a class, now that object is bound to that instance, and now I can call that method. So technically, you can't call a method unless it's bound, really. Okay? So I need to create John or Jane, and now I have an instance. I can call John.UpdatePhone or Jane.UpdatePhone. If I just have address book entry by itself, it doesn't make sense for me to go address book entry .update phone because I don't have anybody's information to update, right? So the same thing applies for here. I don't really have an instance of address book entry, right? I have an instance of employer address book entry, okay? But the thing is, even though I don't have an instance of address book entry, my instance of employer address book entry is the closest thing I have to an instance of address book entry. It's just an instance of a subclass, right? So that's the only object I have that is the closest that I have to the original, an instance of the original base class. So that's why I have to pass itself this time. Remember how I told you that you don't have to pass itself when you're calling a method? Well, you don't have to pass it in when you're calling a bound method. Okay, that means that, John.UpdatePhone, because I have the instance John. Here I don't have an instance John yet. I'm actually trying to make an instance of employer address book entry, but I don't have an instance of address book entry. And because I'm trying to call an unbound function, I need to explicitly pass in that instance, that proxies, that is a substitute for my lack of having an instance of address book entry. So that's why self is the closest thing, because self is an instance of employer address book entry. So I'm passing that in as my argument. So see, I have to pass in 3 parameters now instead of 2. Because I don't have an instance of address book entry. So that's why I'm doing that. Okay? So yeah. So now that I've done that, this will automatically do the self.name and self.phone assignments as well as anything else. That if that method was more complicated, then it will do all the other things. And then I'm ready to add my employee ID and my social security number. Okay? Does that make sense to everybody? Yes, just say yes even if you don't get anything out of this yet. Good. Question in the back.
Sometimes I've seen that you call the base class initializer at the end. Is there any difference? Is there a convention for that?
Okay, so that's a good question. So the question was, sometimes I've seen the base class initializer or any base class method get called at the end of this one. Yeah, so that all depends on how this thing works. Okay, so this thing, for example, create the database object. Maybe you don't want the database saved to be called first because then I would lose this info. So in that particular case, I want to assign this additional data first and then call my base class initializer so that it assigns the name, the phone number, and then perhaps stores it in the database so I have everything. So it all depends on the context. Most of the time you call it first because you want to kind of get it ready and then you customize it. But there may be cases like what I just described where, no, you really do want to do your customization first and then do the other thing because the other thing has to execute with the new data as well. Okay? Did that answer your question? Okay. So the question behind you.
Shouldn't we use a super function?
Shouldn't you use a super function? Yes, you should use a super function if this is further down the line. If it's just the immediate parent class, you don't have to use super, but you can. And then a lot of beginners also don't understand super as well. Super is its own, I wouldn't say monster, but it's its own beast. Okay, so yeah. So if you're further down the tree, you should use super because it executes the MRO, which helps you look up the actual object that you really should be the base class that you should be calling. And then another question in the front or closer?
It's the same question.
Oh, same question? Okay, great.
You're going to cover super in any more detail?
No, that's something I'd like Raymond to do because yeah.
The only one who understands super.
Well, just wrote a recent blog post on it, like maybe a couple of weeks ago anyway. But there is another blog post that you should read in addition to Raymond's too, and that was the super is considered harmful one, so you can see the opposing viewpoint of why you may not want to use super. Okay, it's good to be balanced, right? Because, for example, I was born in America, so when I learned about the Vietnam War, I learned one side of the story. It wasn't until 10 years ago that I actually went to Vietnam, got the other side of the story, that now can make an educated opinion, form an educated opinion on what really happened, kind of a thing, right? So it's really that you want to have both sides of the story before making conclusions. Okay. There was a question? Okay.
I tried to delete what the
okay, yes, attribute error because, so he tried to, this gentleman tried to actually do the delete of John that version again, and he got an attribute error because the John instance did not have an attribute version. And that's because the class has it. The instance did not have it. And again, it's just like I said, a courtesy lookup. It really doesn't belong to that instance. Okay, great. You guys are doing good. Learning something? Yes, yes. Okay, if you say no, then I have some more. Okay. One more question in the back or no?
Yes. I read about the super. It's recommended because when I rename other book entry, then using this form, we will need that I must go through all the subclasses and change the name of the parent.
Oh, when you use super?
The super was recommended because it allows me to skip this step because I rename this book entry and then I must go to all the subclasses and update the code to the.
It should just make, when you get super, you're only going to get one class back. You're not going to get multiple classes back. Refactoring? Oh, refactoring your existing code because you don't have to think about which one it is. Yes, that's right. That's right. Yeah, explicitly naming is only in a very close situation where you know exactly what's going on. But yes, it sort of hides from you, having to do the lookup yourself if you didn't already know what it was. All right. Okay, so now let's do something more fun. Okay, that is making your instances act like Python types, like a Python number, a Python list, a dictionary. Okay, these things are very fun. All right, there's special class methods made for this purpose. By default, they're not defined, or you can think of them as defined but we're passed, so they don't really do anything. Okay, and you really customize your class when you override these, and that process possibly overloading the existing Python operators as well as built-in functions to be used for to manipulate your instances with. Okay, for example, 1 plus 2, that's great. Food quote plus bar quote. Okay, so I'm adding numbers and then I'm concatenating strings so the plus sign is overloaded, so it does something for numbers and it does something different for strings. So you can do the same thing with your classes. You can make your instances use the plus sign and have it be a valid thing. Right? So these are those special methods. Okay, so we already know about under init, which is the initializer. There's a special one, a special version called under new, and that's used when you're subclassing immutable objects. So you know that immutable objects you cannot modify, right? But with under init, it's fine because Python makes the object for you. It calls your under init. You can do your self.name, self.phone assignments. You're actually changing that instance. But if your object is immutable, you can't do that, right? If you can't change this object because it's frozen, I'm not going to go and do a self.name equals and a self.phone equals after that because you're going to get an error, you're going to get an exception, and it'll say something like, this object does not support assignment. Okay? And so to make up for that, you use under new because this is basically where you set up the creation of the object. Then you tell Python to make it. Okay, so it's kind of like when you're making a popsicle. You put your juice in the ice tray, you put the stick in it, you put whatever you want in it, then you put it in the freezer. Okay, and then it comes out. So this is kind of like that. So before you freeze your object, you set it up using under new. So new is like init, but it's for when you're creating subclass immutable objects. And then there's a terminator, which nobody uses because that has its own problems, right? Everybody knows that you're not supposed to write terminators, okay? Because you cannot predict when it's going to be called, because it's only called when the reference count of your object goes to 0, which is when no variables are interested in your object anymore and can be deallocated. is, you can't predict that. Okay, so that's one reason why you don't call the under del. You don't know when it's going to execute. Furthermore, let's say that your entire script is ending and Python is going, the interpreter is going through and hitting free on everything. It's possible that by the time your reference count goes to 0 and your under del is called, that Python has already freed objects that you're using inside your terminator, which results in an exception because those objects are no longer there. So in under dels, exceptions are ignored, which can be very bad, right? Because you could be ignoring a real error situation, or you could be ignoring one of those, oh, my object was free already, but you don't know which one it is. So that's why it's not recommended to use those. Right? If you do have to do some sort of exit thing, there is an exit hook that you can use to kind of specify that. Right? So that's why you don't write under dels. In fact, when you look at the documentation, if you actually go through the Python documentation, you get this big warning box: do not implement under del, unless you really, really know what you're doing. Okay? All right. So enough with the setup and the takedown stuff. Let's talk about some of the more interesting methods, like under str. So under str, if you create this this method in your class definition, you have just overloaded str to do the printable string representation of your object. Okay, so I'll show an example of that coming up. And what that means is so everybody knows what your objects look like. Let me see if I can just demonstrate that here really quickly, because this is part of my delay tactic. Because I have 90 minutes. And I'm going very slowly by just starting the interpreter up. It's going to take a while, which is great. See how I'm doing on time. Oh gosh, I have a lot of time still. Okay, so it takes a long time because I have a slow machine. It's a PC. Okay, that came up faster than I thought. And I have 2 people. All right, so let's create a class C object S, and then I make one. Okay, when I do print C, how is that useful to me? Right? It tells me what kind of object it is. Cool. It tells me what the ID is. That's pretty nice. It doesn't tell me anything. What if I do important stuff? Like I'm going to put in my very important variables in here. Okay. Now let's print it and see all my new data. What? What happened to my data? It doesn't do it. I'm not getting any information out of this. Useless. Okay?
There's information. 0801375.
Okay, Harold, that's great. What are you going to do with that? Tell your friends. Yeah, and you can put frame and put it on the wall like art. Okay. Not very useful, right? So here's another inside tip. Did you know that when you call print on any object, it's the same thing as doing sys standard out right of str that object? Do you guys know that? Str is always called on print. Okay? Always, even if you didn't do it yourself. Okay, so str. So the reason why I use print was because when I override under str, that makes it work with print, basically. Okay? And the same thing goes for REPR. All right, you can create the under REPR method, and that will overload REPR, so you can use that for your instances. Right? Now it's kind of neat because I'm used to calling str quote 123 or str for any other object. Now I can call str on my instance, which is kind of neat, I think. All right. And then similarly, let's talk about equals equals and not equals. Okay, so what if I want to overload the equals sign? What if I want to have the concept of my instance equals something else? Another object, x equals y, where x and y are instances of my aggregate entry class or something. Okay? So you can override under EQ, under NE, and the same thing goes for greater than equal to, less than equal to. So it's GE, GT, LE, LT, under. Okay? So now my instance is going to work with those objects. Now it's starting to act like a Python type, right? Okay. And then if I want to use the plus symbol, all I have to do is override, I'll create the under add method. Now I can have my instance plus something. Okay. Now if I want something plus my instance, I have to also create under add for right-hand side operations. Okay, now if you have commutative objects, which means 1 plus 2 equals 2 plus 1, like numbers, you would generally just make one of them and then make the other one like you would create under add, and then you would just make rn point to under add. Okay, but if it's different or not commutative, like strings, quote food plus quote bar, that's different from quote bar plus quote food, right? Then these two will have to be different. Okay? Or furthermore, if you want instance plus equals something, then you would overload the under I method. Okay, I add. So the same thing happens for sub. There's also a sub, r sub, I sub, and then for multiply it's mul, r mul, I mul, and then divide is div, r div, I div, and then there's also floor div, r4 div, I4 div for the double slash operator. So the same goes for modulus. Okay, so you can overload these operators by just defining these special methods. Okay. And then the last bits are if my object has a concept of a length, some sort of cardinality, then I should overload the under len so that I can use the len built-in function with my objects and get some number out of it to tell me something, whatever length means for my type of class. Okay. Similarly, if I want to be able to use the bracket operator to pretend my object is like a list or an array or a dictionary, okay, then I overload under get item, and then I overload under set item, so I want to have assignment to my instance, whatever that means for that object. And then similarly, if I want to be able to do slicing, I can do get slice, okay, and I think there's a set slice as well, right? If I want to have the concept of indexing and setting multiple elements in my instance object. Okay. Then finally, if I want to be able to check for membership and use the in operator with my instances, then I can create the under contains method. Okay, does everybody understand what I'm kind of saying? Okay, let's look at a real example. Okay, so I want to measure like hours and minutes. Like I have contractors coming to my house to make a repair, and they're going to bill me based on the time that they have worked altogether. So I need to track hours and minutes. Okay, so I'm creating a simple class here, times 60, that measures hours and minutes. Okay, sub.hour equals hours, sub.minute equals minutes, so I'm expecting to pass this in. Now, something to think about on the side, how can I make my initializer more robust so that if I have input from a different source, using different ways of input, like one single string instead of 2 integers, how would I do that? How would I make my constructor support additional forms of input, right? Because Python doesn't have overloading, so you're not going to have multiple signatures. So you're going to have to be able to kind of build all that in one single body of code. So there's something to think about. Okay? But in the meantime, what I really want to do with this whole thing is do something like this. I'm going to import my class, and then I want to create an object that represents 10 hours and 30 minutes. And when I do a print on this 10-hour and 30-minute object, I don't want to see something like this. Because this is not going to tell me anything about my hours and my minutes, right? Okay, I actually want to see, 10:30, because that to me means 10 hours and 30 minutes, or I guess in some countries it's 10:30. Okay, but it doesn't really matter. Whichever one you want, you need to customize your under str to do that. So that's what we've done here. Okay, so I've customized my under str so that it does hour, minutes, so that when I print it out and print calls str, which calls my under str, it actually gets something that makes sense to me, right? Because if I get what I got before, less than sign times 60 object at some hex number, that's not useful for debugging. This is much more useful for me because it tells me the most critical information about my object, right? Okay, and then furthermore, I want to create another one, let's say 8 hours and 15 minutes. Okay, so that's my second instance. I want to be able to add them together and make a third instance of times 60. So you can't see it here, but it actually is a third instance, all right? And I want them to be added together so that it tells me 18 hours and 45 minutes, like that. Okay, so in order to support the adding of these instances, I need to have an under add. Okay, and here's where I instantiate, make the third instance. I'm calling my class. you can put times 60 here as well, but it's better to do some left for class because you may not necessarily know the name of your class, right? And then, or maybe like what if you want to change the name of your class because you don't like it? Now you have to do search and replace. Okay, so it's easier just to get the reference to the class object from the instance itself. So now you can fill in the blanks, right? And really guess what the blanks are. Self and other, self and other. Self dot hour plus other dot hour, and then self dot minute plus other dot minute. Okay. But of course doesn't support base 60, so you need to add. So one of the exercises in chapter 13 of my book is I think part F of chapter 13, exercise 20, part F is to support base 60. Okay, so that if I have like 10 hours or 30 minutes plus 8 hours and 45 minutes, I'm not going to get 18 hours, 75 minutes. I want to get 19 hours and 15 minutes. So then you're going to have to do your mod by 60, divide by 60, and all that additional stuff, and you put it in here. Okay, so I'll let you guys fill in the blank mentally. All right, it's an exercise. That's what I do. I make you guys do work because I'm too lazy to do it. Okay. All right. So anyway, so now you see the power of these magical methods to make your object act just like Python types. Right now, I can't tell it's not a Python type because I'm printing it. I see something useful. I'm adding it. I see something useful. Okay. That's pretty cool. All right. So that's the end of the bonus material. Okay. Now let's get to the real reason why you're here. Okay. So good. If we have 15 minutes or 40 minutes. Maybe 50 minutes, quite long, so let's see how well I do. All right, so let's talk about performance and how to use the stack, or really how not to use the stack, because if you can minimize your use of the stack, then your program runs faster, right? Because everybody knows that there's some context switching time. You have to push objects onto the stack. You got to push the function you're going to call on the stack. Your program counter has to change, and then you have to like save registers and all that kind of stuff. And then when it comes off, when the function is done, you have to pop that off. You have to get the return value and all those kinds of things, right? So really, you want to try and minimize it if possible, right? So here, let's talk about that for a little bit. So as you know, since you're all computer scientists, the stack starts at the bottom and it grows upwards. Okay? Every time you call a function, push the arguments on, push function on, and then you go. And then if that function calls another function, then you have another stack frame. Okay, so it's called stack frames. 1.5, not stack frames. So when you're done, these get popped off, and the stack goes back down. Okay. Now, in regular C Python, there is one Python stack frame. Every single Python stack frame means that there's going to be a C stack frame call as well. Okay. The reason why I put the star there is if you're using a different version of Python, that may not be the case. Like if you're using stackless, you can have like any number of Python stack frames for one C stack frame. Okay, so that's why there's a star there. Now, of course, if you're making a lot of function calls and your stack goes really high, and of course, way up at the top, you're allocating dynamic memory with your heap going downwards. Okay, if you go too far, when the two get together, then that's when you're going to have memory error. Okay, so you have to be careful about that. And some other general good tips are try not to have global variables. Okay, so that applies to C as well. In Python too, slightly different reasons, but Python, C Python is written in C, right? So it follows some of those rules. And of course, versions of you can have recursion as well, but it doesn't matter in Python or C because even if you're calling a function with the same name, even though that's mentally hard for a human, it's just yet another stack frame for the interpreter. Okay. So let's just take a look at some examples here. So pretend X is a really, really long string. Pretend you just did an f.read on like a 1 gigabyte file, right? So it's probably not recommended to do, but let's just say it's very long. Let's take a really quick look at these two snippets of code. You kind of think in your head visually which one you think may be faster. So I'll give you guys 10 seconds to think about it, and then we'll talk about it. Okay, how many people think they will take the same amount of time to run? Okay, 2. Okay, probably need to phone a friend or ask the audience. Okay, how many people think the first one's faster? 2 again. How many people think the second one is faster? Whoa! Okay, so we should have done ask the audience, not phone a friend then. Okay. All right, so let's talk about this. They definitely do not take the same amount of time to run. time it module. How many people have used the time it module? All right, that's funny. Most of you are on this side. There was no sign on the door that said people who use time it sit on the right side of the room. People who not use it on the right side. It's really weird. So time it is a module that you take a Python snippet of code, you pass it in, it will run it 1,000,000 times, and it'll tell you the average runtime. Very useful for when you have like 2 different solutions or 3 different solutions of solving the same problem. You want to see which one runs faster. Okay, so time it, T-I-M-I-T. Okay, very useful. All right. So for all of you guys, why do you guys say that the first one is slower?
Function call was that easy to do.
Okay, right, but isn't Python smart enough to cache this? Okay, that's another question. It's another question I get asked from beginners in my class. Python doesn't do that. All right. Well, the reason is because it's possible, however, not very likely, that you can change len, right? You might change the function because, it's not a reserved word, so you have to make it point to something else, right? So something like elated swallow says, oh, no, that's probably not likely that they're going to change that function, so let us do cache that to make things run faster. So that's one of the performance improvements that the elated swallow project was trying to make Python run faster. Okay. So yes, so the reason why the first one takes longer is because I'm making, push on the stack frame, pop off, push on, pop off, push on, pop off, and this length function is going to be expensive if Python doesn't keep track of how long the string is. All right, if it doesn't keep track of how long the string is, it's really going to take a long time. But if Python is smart, it does say the size in part of the struct, then you're only paying the penalty of the stack frames. But if you call it 1,000,000 times, that adds up, right? And you'll notice that if you guys pass both of these into time, you'll see the penalty that you pay for that. So yes, so in the second case, I'm capturing that value into an integer, a variable, and then I'm just referring to that variable instead of having to call functions. So by reducing the total number of function calls, you've made your program run faster. So this is what I mean by trying to not use the stack. Okay, it's easier just to cache it. Okay. Now I'm not going to ask for those of you guys who think the first one ran faster. I'm not going to ask you why. But I did have a student in one of my classes say, well, it's obvious the first one runs faster. There's fewer lines of code. Right? I mean, you can kind of see their argument, but they weren't thinking in terms of the stack. Right? So when you're writing your code, it just means, yes, you may be able to come up with how to do it in Python pretty quickly, but is it the most optimal way? So sometimes I find myself refactoring my code as I'm writing it, not waiting until afterwards. I'm refactoring it as I'm doing it, thinking, you know what? I think there's a slightly better way of doing things. And this is not a big change, right? With just one extra line, one extra or 2 different lines of code, I can really change the performance of my Python code. And that happens a lot every day. This is just one example. So for you guys, the same thing applies too. When you do something and you have a solution, is this the most optimal way of doing it? Am I making it run faster? Am I reducing how many function calls I make? Am I making a list versus making an iterator? Okay, these are design decisions that you can figure out later on when you're doing real refactoring. But sometimes you can think about once you get to enough Python experience, you will already be able to tell. In fact, you'll be able to debug your own code while you're writing it. Okay, so that takes a while to do. We had a question in the back?
Yes, if the processing inside the loop takes, let's say, 2 seconds, will I see a difference between these codes? Because I don't expect to be so important.
Right, exactly. So the question was, will I see a difference if I only, if the loop is very short? Probably not noticeable. Okay, it only happens if this ends up being like a bottleneck or something that happens to be called all the time. So it's more. So I'm not telling you that this is going to solve all your problems, but all your performance problems. You're not going to see the entire application run a lot faster. But this is one place that you remove the bottleneck. And that's one of the secrets of making Python scalable. Because a lot of people complain, back in the old days it was Python versus Perl, and why was Python always slower than Perl? Okay, so this is one of those optimizations that you make to help start making your program run faster. And of course, every release, the core Python developers, make performance improvement in the interpreter itself. But that doesn't preclude you from being lazy and not, making your code run as fast as it possibly could from what you can control. Okay. So you just have to you have to think about it carefully. So the example here is just to show you that with a small change, you can change, slightly improve the performance of your code. Okay, another question?
Comments. This may depend on which implementation you're running, because, for example, the Allocation will do all kinds of magic optimizations and do that without calling.
Right. So the comment is, if it's a different implementation, it will not necessarily behave this way, because Java has certain optimizations, and I'm sure the CLR does optimizations as well for using Python, etc. Okay, so that's correct. So this really applies to C Python, right? But I'm going to assume most of you are C Python users. All right. So I just want to show you this example. And then, of course, I have another student that said, well, it's obvious that the second one runs faster, because it has a green light. The first one's a red light. And I have really interesting students. I did not see that at all. Okay? And it would be really bad if I changed the color so I leave it the way it is. Okay? Maybe that'll help them in some other way that I can't understand. Okay? Alright, so that's great. Now let's talk about Python objects. So one of the things, I don't know if whoever you learned Python from, maybe it was yourself, but did you know that every Python object has these three attributes? All of them. There's no exceptions. There's no object that does not have these three attributes. They all have an identity, which is the hex number that we saw. It's just a number that uniquely identifies this object from any other object in the system. There's a type, and there's a value. And the thing that's most important is, of all three of these values, the attributes that all objects have, they're pretty much all read-only. It can't be changed. The only one that may be changed is the value. Okay, and that's the difference between a mutable object and an immutable object, right? Can I change this object, or can I not change this object? Most of them you can't, right? There's only a few Python objects that are really mutable, like lists and dictionaries and instances and classes and things like that. Okay, those are usually the only exceptions, okay? And all Python has about 30 object types if you didn't know that, so you can take a look at that at the link there. I'll have the slides uploaded, maybe at the end of the day or something, so you don't have to worry about writing anything down. Anyway, so if you were to, somebody asked you, I'm trying to learn Python, how many numeric types does it have? And you have to tell them, between 3 and 8. Okay, because there are, right? And how many string types do you guys have? 2 or 3. Okay. Because there are. And then there's lists and tuples and tuples, dictionaries, and then there's 2 set types, and then there's other things which are also objects, like none and files, functions, modules, constant types. Everything's an object in Python, right? So, anyway, so those are the objects. And all objects that are allocated on assignment, so you don't have pre-declared variables, dynamic typing, duck typing, all objects that pass by reference. We already talked about that. References are also called aliases. Okay, and reference counting is used to track the total number of variables that are interested in your object. How many references do I have to my object? Okay, this reference count will either increase or decrease based on how you use it and where you use it and where you pass it into. And then of course your objects are garbage collected when the reference count goes to 0. They're flagged for garbage collection when the objects go to 0. Doesn't necessarily mean they're garbage collected. So here's an example. X equals 1. Okay, so one of the things I tell my students is, when I learned programming many years ago, I was told that a variable is a box, and you drop a value into a box, and that's it. So I have a box named X, and I drop the value 1 into my box. All right. Unfortunately, with Python, it doesn't work that way. You have to unlearn all that thinking. Okay, you have to kind of it's because it's backwards, right? You can't teach programming that way now when you use Python because it's more object centric, right? When you do x equals 1, Python will say, I'm going to make an integer object 1. It has an attribute, a type, and a value that I just described. And x is just a sticker I put on it, like a post-it note, those yellow post-it notes that you put on it. That's what they are. You can put another one on by doing y equals x. Okay, so now I have 2 post-it notes on an object. I don't have 2 boxes x and y, and they both have 1s in them. I have a single integer object 1 that has x and y as labels on that integer object. Okay? So, again, variables don't hold data anymore. They're really just pointers or aliases or references to an object. And of course, you can have additional aliases of the y. And again, when x and y are gone, let's say they're part of a function, the variables, their local variables will go away, and nothing else is interested in my object anymore, then it's flagged so reference counting is an easy way to do memory management. The only drawback, one of the drawbacks is that you can have cycles. So if you have an object, point to an object, point to an object, and then that object eventually points back to the first one, and then all variables pointing to these two go away, and all the other ones go away. The problem is they all still have reference to each other. You can't get to it anymore from your application. The problem is the reference count is going to go to 0. So you're leaking that memory. Okay, so that's a one drawback of having to using reference counting. So I have a cycle detector that will go through and check for this type of stuff. Back in the old days, before Python had a cycle detector, this was not the case. So you could run into problems, all right. But if you think you're a perfect programmer and you write bug-free code, then you can actually tell Python to turn off the cycle detector and do the trapeze work with no net on the line. Okay, but it's probably very dangerous to do. So anyway, so let's talk about reference counting and what makes reference counts go up. Okay, so when you make an object like this string here and you assign it to the first variable, well now my reference count is 1 because I made this object, and now I have one alias to it, one reference to it. So reference count is 1. I can now make another alias point to the same string, and now that makes my reference count go up to 2. Or I can pass that object into a function, and now it becomes a new local variable in that function, so again the reference count goes up by 1. Or I can put it inside a container. Okay, so now I need to be able to refer to that object from somewhere else, so that makes the reference count go up by 1 as well. Okay, so in your head you need to kind of like mentally keep track of this type of stuff, because if you end up writing a C extension, you have to manually manage the reference counting yourself. So for those of you who've done it, it's incorrect and correct. It's a very common thing to do. Good question back there?
Yeah, I was just wondering, can you actually get the reference count for your variable?
The question is, can I get the reference count of an object? And I believe it is sys.getRefCount. Anybody confirm that, or do I have to do import sys eurosys? Okay, sys.getRefCount. You know what's fun? Let's see the ref count of 0. Always fun to see these ref counts, because you're thinking, wait a minute, I just started the Python interpreter. Yeah, right. You ran a lot of stuff that you didn't think you were running.
So the interpreter is rather false or true?
Pardon?
Your interpreter is rather false than true. 79 to 56.
It's more false than true, yes.
It's more now than anything else.
Yes, that's true. That was a clever observation. It's more none than anything else. And I got my instance C. Not too many things. Not too many things interested in my instance C that I tried to print out, apparently. Okay. Those is kind of fun, so you actually get the reference count of an object. That's a good question, actually. I should have put that in my slides. How to get the reference count. All right, now let's talk about when the reference count goes down. So in the previous slide, I passed in the string to a function, and then the function ends. So that local variable spawns, so that decrements it. I can just remove the alias that I made. Remember I did var equals foo, and I can do del var, or I can do del foo, and just remove one of those references, and now my ref count goes down by 1. I can immediately assign var to something else completely different. Okay, so now it's not looking at my string anymore. Or I can, remember how I also put it in this container, the list? Well, I can also remove it just as easily. Or maybe the entire container goes away. And so all those things make the reference count go down by 1. Okay, just something to think about, right? Okay. And so anyway, so just forget all that. Doesn't matter. Okay? We're ending that section. I'll talk about the next section. Okay? So good, we're good on time. Good. So now, I'm going to categorize all the standard types for you, but I'm going to do it in 3 different ways. Why am I doing that? To make you learn them faster if you're still new to the language. If you're not new to the language, hopefully, I would show you a different way to think about the relationships that each of these standard types have with each other. Okay? Another goal is to make you understand them better. And if you understand them better and you know how they work under the covers, you're going to write more correct Python code. Again, I'm trying to create, I shouldn't say bug-free Python programmers. I'm trying to make you guys write fewer bugs that you haven't written yet. Okay, that's my goal. Okay, so because if you understand them better internally, your code is going to be more not only efficient, it's going to run faster, it's going to be more correct. Okay, I want you guys to be the perfect programmer. Okay? In fact, that's what I tell my QA testing people. I tell them, you know what? I don't need your services. I write bug-free code. And they all go, and then I just wait for them to file tickets on my stuff. Maybe once every 6 months or so. Okay, it doesn't really happen, and some of them can't understand it. And every time they find one, they think it's victory. And they go and yell and run around the office screaming, I found a bug in Wesley's code. It doesn't happen very often. Right? So that makes me happy. Because I know it's not realistic for me to say that, but it is a goal that I have. Because you got to shoot for something, right? Otherwise, you shouldn't be in this business. Okay, you just go back and do underwater basket weaving. Okay, now let's talk about the 3 different ways to categorize the standard types: the storage model, update model, access model. You won't find this in any other book because I'm a mad scientist and it's only my wild and crazy imagination, and so I put it in my book, so it's not in any other book. Okay, storage model. How is data stored in an object? In other words, can it hold a single object or can it hold multiple objects? In other words, what I'm really trying to ask is this a container or not? Okay, so literals and scalars are not containers, so that's all number types and strings. Container types are everything else. Lists, tuples, tuples, dictionaries, sets, those are all container types because they can contain more than one Python object. All right, everybody understand this model? Fairly straightforward. Here's another model, the update model. Can I update this object's value? Again, every object has a type, an ID, and a value, right? And all of them are read-only, except maybe the value, so here's where this comes in. And that is whether that object is mutable or not. If it's mutable, yes, you can change it. If it's immutable, no, you can't change it. Okay, and of course, there's one of each set type. There's a mutable set type called set. There's an immutable set type called the frozen set. And starting in Python 3.0, there is a byte array type, which is a mutable string type, or it's really not a string, it's a byte, it's an array of bytes. Okay? So that's the update model. Can they be changed? Remember how I said there's very few mutable types: lists, dictionaries, sets, instances, and classes. Okay? Everything else is pretty much immutable. Okay? There may be a couple others as well. Right? So just keep that in mind. Because believe it or not, mutability of an object is a source of many, many Python bugs. Many Python bugs. Last one is probably the most normal way, and this is how you learn Python in most books and most documentation. And that's how you access an object. You access them directly, so probably a number or a set. Oops, it's a number or a set. If you access it by index value, bracket 0, bracket 1, that's a sequence type. Okay, strings, lists, and tuples. Or use a key to access your value, so that's a mapping type, dictionaries. Okay, right? Everybody understand this one, right? How do you access the object? Either get it directly, or go by index, or go by key. Now, so we looked at all 3 of these models, and they kind of were a little similar in some ways, different in other ways. But the interesting thing to do is to actually look at them all combined together. Okay? So by doing that, you can kind of see the interrelationship that each of the Python standard types have with each other. You can see that lists and tuples are very similar to each other. Okay, they're both containers, they're both sequences, but one's mutable, the other's not. Another one is like dictionaries and lists. They're similar too because they're both containers, they're both mutable, but one's a mapping type, the other's a sequence type. Okay? So this chart here helps you understand how they are alike and how they're different in different ways. Okay? So understanding this chart will give you a better understanding of the Python types. Okay, so that's all I wanted to say about that. Let's take a quiz now. So let's take a look at example 1, example 2. So I want you to look at it for each one for 10 seconds, and mentally in your head, figure out what the output is, and then tell me what you think the output is, in about 10 seconds. I'll let you look at it, and we'll talk about it. All right, so what's the answer to the first one? Okay, 43 and 42, okay, that makes sense, right? So if I had a whiteboard here, I would do this. I would pretend I was the Python interpreter. That's how you figure out what the code does. You have to be Guido. Okay? So x equals 42. So the first thing that happens is, no, I don't assign 42 to x. I see, do I have an integer 42 in my system? So I'll pick it up, and I make x point to it, right? It's a label. Okay? Then I do y equals x, and I make another label pointing to x. When I do x equals x plus 1, I go, okay, I'm going to take the value 42, add 1 to it, then I have an object 43, and then I make x point to that, and then y is still pointing to 42, so the sticker is going to move. Okay? So let's take a look at the second example. How does that work? What's the output? Same, which is 43. Okay, right. So the way I execute that is I make an object list, 1, 2, 3, I make x refer to it, then I make y stick on that as well. When I refer to x bracket 0, I'm looking at the first element, I'm swapping the 1 out and replacing it with a 4. But because I've changed x, and y I'm looking at exactly the same object, that's why my output is the same here. But it's different here. Why are they not the same? Because of what? M? Starts with M? Mutability. Right? Again, this is the cause of most Python, or many Python bugs, is mutability. You forgot that numbers were mutable and lists are mutable. Okay, good. So now let's look at another example before we go to the next slide. Let's do the same example, but let's do it slightly differently. So instead of x equals 42 and y equals x, let's do x equals 42 and then y equals 42. Now what happens? Do I have 42 and an x pointing to it, and another 42 and a y pointing at it, or do I only have one 42 and then both x and y are looking at it? If I have x equals 42 and y equals 42, not y equals x, but y equals 42. How many people say there's only one 42 in the system? How many people say there are two 42s in the system? Not a lot of people on the second one. Okay, so I'll say that most of you are right in most cases, but the rest of you are right in other cases. So you're all right. Everybody's a winner. Okay? So, if I do x equals 4 and y equals 4, is it going to be this one or this one? Pretend that 4.3 is really a 4. Okay? So, this is an exception to the rule. So based on what I've told you so far, you should be saying there should be two of them, like some of you have. And you would be correct, except this is an exception to the rule. And the exception is special numbers, which are all numbers between -5 and 256. And there's only one instance of those objects. They're all singletons, and they're all permanently installed in the system, which means they're never deleted. Which means even if the reference count goes to 0, they will not be deallocated. These are special and called integer. Okay? So the reason why this is not good currently is because, well, first of all, this is undocumented. Okay? So you won't find this anywhere. Except in my book. And the other thing that's bad is that because it's undocumented, or maybe the reason why it's undocumented, is the core Python team changed this on me. Okay? So before Python 2.5, this range used to be -1 to 101 for intern. Anything bigger than 100 and smaller than -1 were not intern. So you would actually have two of them. And so this is only integers, and also often use single character or empty strings. Those are the only objects that are intern. So if I use floats, then you actually will get two. So those of you guys that think you were originally wrong, right now. And it's also the float. And it was something else, the dictionary, a list, or whatever. Okay? So it's undocumented. And of course, when I was working on the second edition of my book, nobody told me that they changed it. So I was looking for the 101 in the source code, I couldn't find it with my grep magic tool. And then I found out that it was changed to 256, so that was kind of disturbing. So, yeah. So it is undocumented. But it's one of the things that may be a cause of one of your bugs, but you don't know that, right? So it's not documented because you shouldn't need to know this stuff. But there may be cases where you need to know whether or not both x and y are looking at the same object or not. And so that's why the is keyword exists. Okay? So is will tell you whether or not they're both looking at exactly the same object. When you do x equals 4, y equals 4, and you do x equals x is y, you actually get a true. But if you do the same thing for 4.3, you get a false. Now for equals equals, you get true in both cases. But for is, you're only going to get a true for this one, you're going to get a false for this one because there are two objects, so they're not looking exactly at the same one. Okay? And then let's take a look at the second quiz here. Now I'm going to make a copy. Okay, so people, beginners to Python will ask me, how do you make a copy of a list? Well, you can just do a list of your existing list, or you can just take an improper slice, which is a slice of everything. Okay? And so now I'm going to go and change this 1 to a 4, y, bracket 1, after I've copied it, change it to a 4. I'm not changing the 1 in x, I'm changing the 1 in 4. So now what is the output? The same? Are you sure? I'm going to copy. How many people think the output is going to be different? How many people think it's going to be the same? Oh, that's not good. That is not good because half of you are wrong. Now you know which half is wrong. Why? Okay, so this gentleman here said the list is a list of references, but that doesn't, let me explain it in different words, saying exactly the same thing as him. When I copied the list, I copied the references. I did not copy the objects. Okay? Both x and y, even though they are different data structures, when you do x, x is not y. You'll get that. X is not y. They're different lists. The problem is inside them are the same pointers. They are both pointing to the same list here. So even though I changed y, because y refers me to this list, but x also refers to that list, even though x and y are different lists. Okay? This causes both of them to be changed, but it's not really both of them that are changing. It's not only changing the one thing that they are both looking at. Okay? Again, so because half of you raised this, because half of you raised your hand, this would have been a bug. This would have been a bug in your application because you weren't aware of this. Again, what is the cause of this bug? Starts with N. Exactly. Okay? Everybody learned something today? Shocking, isn't it? Okay? Yes, question.
How can I do a deep copy then?
How can you do a deep copy? That's on the very next slide. And a lot of my in my classes, actually, when I teach my class, I tell them, all right, I know we're just starting the class, but let me tell you, whatever questions you guys have, I'm probably going to answer it in the next 3 or 4 slides. Really. And people don't believe me, they ask anyway. Okay? So, Harold.
Is there any way to find who is holding the reference to an object?
Is there any way to find who's holding a reference to an object? I don't think there's an easy way of doing it. You're just going to have to check IDs. Okay. There might be a way, but I'm not familiar with what it is. Okay. All right. So first step is be aware that when you make an alias, you're certainly not making a copy. Right? When I'm doing B equals A, all right. A equals B, that's true, and A is B, okay, because the ID of A equals ID of B. So some of you guys want to find out how to get an ID of a value. Somebody asked how to get a ref count. You already know how to get the value of a variable. You know how to get the reference count. Now I'm teaching you how to get the ID. Okay? So ID A equals ID of B, the same thing as A is B. So these both exactly look like the same object. You're not making a copy, you're just making an alias. If you make a shallow copy, okay, A is still equal to B. But A is not B, because, like we did on the previous slide, A, X, and Y are different lists. But what they're pointing to are all the same, right? Okay? So now if you really want to copy, there's a copy module, and inside the copy module is a deep copy function. Okay, so you just call copy.deep copy to get to that. So yes, you did ask me a good question, and no, I didn't pay you to do that. But to be honest, I don't know if this is the case with other languages or not, but in 14 straight years as a software engineer in Python, I actually not needed to use deep copy at all. Because most of the time when I'm going through a list, I'm really wanting to just extract values from it, like using filter or using a list comprehension or generator expression. I'm not really needing to actually make a real copy of the thing. And the thing is, this is restricted anyway. There are certain objects that deep copy cannot copy. Like if you had a file object in there, you can't really copy the file object, you know what I'm saying? So you have to be kind of like cautious with using deep copy anyway. Or you can copy simple objects, but anything more complicated is complicated to do. Okay? Alright, so that's really the end of the talk. So I do have part 2 that I didn't get to. So I will start doing that while I take more questions. And I know we're wrapping up. I know we have a few more minutes, but I'm going to see how close I can get to running over time. So let me just make the second presentation here. So my second presentation, I did this all last night after coming back from dinner, so I did it all in plain text. Okay. But nobody wants to see a presentation in plain text, right? So let's make a PowerPoint out of it. Oh, I have a funny Python script that actually just makes plain text. It makes me a PowerPoint presentation. So I don't have to really do any kind of editing in PowerPoint. So anyway, let's take a few seconds because there's only a few slides here. But I'm lazy because, you know, I had a little bit of red wine last night. And I really wouldn't be able to manipulate PowerPoint in the mouse. So plain text I can handle when I'm drunk. Okay. PowerPoint is not as easy to do. Okay. So good. Oh, the reverse problem? I can't go the other way? Yeah. Okay. So, let's spend the last 5 minutes talking about Raymond's talk from 2008, which I wish he would repeat, but since he's not doing it, I'll do it for him. But using my way of doing things. Okay, everybody gets to do it their own way. So just thinking about mutable containers. So I'm going to blow through these pretty fast because we only have a few minutes. But again, it's very important to know some of this background data. So let's talk about lists a little bit and how they grow and shrink. Because if you know how lists work, then you'll try to avoid them, right? Okay. So memory allocation. There are good memory allocators and there are bad ones. Okay. So it all depends on your operating system and things like that. Some things are out of Python's control. Okay. So the good ones will, you know, really grow things in a smart way. Okay. So Python just pretends all the memory allocation is bad. Okay, so it tries to be as good as it possibly can, okay, regardless of the operating system that you're using. Okay, so the trick is to leave room to grow. Okay, so when you make a list, it's going to allocate just a little bit more, and you can anticipate that you've got to append a couple of times. Okay, so for example, if you create an empty list, there's no memory allocation except for the struct that you use the whole list with. If you do a .append on an item, instead of making just one slot, it actually makes 4 slots, okay, for you. So that if you do .append again, you don't have to go and reallocate more memory. Okay, so that's an optimization. And then only when you get to making the 5th one does it get another 4, okay? And then so you can do another .append without paying any kind of penalty. So it looks like it doubles every time it calls another C realloc, right? It looks like every time you go to the next one it doubles, but it really doesn't. Because as you get really big, you really don't want to double, right? Because if I do 100,000 append, am I going to do 100,000 appends so that when I get to 100,000 I'm going to go to 200,000? Am I really going to do another 100,000 appends? Probably not likely, right? So we want to kind of tail that off as we get bigger. Okay, so this is what the pattern is. So it doubles to begin with, and then it slowly starts to reduce the doubling. Okay, and as you get larger and larger, it really does not go over more than 12.5%. Okay, to be more efficient that way. Okay, and this is really good performance for a pen because it's just all at once. So it's very nice. Okay, so let's take a look at what that is. Okay, so when you go from 0 to 4, 8, 16, keep on going. So there's this function where the new allocated size is 0. I have a while true loop. Print the size of what the allocator is. But I want to figure out, what is it when I append something? When I do give me an extra value on a list, give me a value on a list. What does it make a new size? Okay. So what is G? What is my growth? My growing function. The growing function can be defined here. If you go to listObject.c, you can actually see the actual algorithm. That's this magic thing here. So G is just this function that takes your size, it multiplies it by, or it shifts it by 3, and it checks if the size is less than 9, otherwise 6. So you don't have to really understand what it does. All you know is that it does this, which is the list allocation mechanism. Okay. Note that if you do have a lot of 1 to 2 item lists, you really waste a lot of space because you're going to have a bunch of like these dots everywhere that's like not used. Okay, so try not to have a lot of short lists. Okay, everyone understand that? Okay, good. So shrinking is kind of similar, but it's easier. It only calls realloc to recompact the space only if you have less than what's allocated. So you go to the source again, you see that whatever I have alloc is that greater than what my new size is going to be, if it's not less than a half, which means greater than or equal to shift it by 1, then just don't even call realloc, just return, keep the size the same. Okay. So removing is pretty easy. It's also O1 when you pop at the end. So when you do a pen and pop, it's pretty good for lists. If it's in the middle, you pay a penalty because when you do things in the middle and the beginning, you have to shift everything, right? So if you insert at the beginning, you have to shift everything to the right. When you delete at the beginning, you have to shift everything to the left. So unfortunately, the performance gets much worse at both ends. Okay, so that's the problem there. So Raymond actually created this double-ended queue object, which you should use if you do a lot of this inserting at the beginning or at the ends. So this double-ended queue is really made for O1 access for pushing and popping at the beginning or at the end. So you should look at that. But it's slower for accessing stuff in the middle. But and then there's stuff about sets here. I guess I'll just give you guys the slides. Slides are pretty fast. Sets are pretty fast. It's O1 for membership checking. When it grows to 2/3 full, it jumps by 4. But you have to keep in mind that dictionaries of sets and lists actually got sets. It should be lists. So I'll change this in the slide before I upload it. They're very expensive. You can think of them like Italian sports cars. Okay, they're very expensive, but they're very fast because they've been in Python for so long. They've been finely tuned. Okay? In fact, Tim Peters says that a Python dictionary is way faster than a C object that you haven't really optimized. Okay, so really, really fine-tuned on this. All right, so review all your code, and then I have some examples of more examples of how to optimize. So I guess I talked slowly enough so that I didn't have to use the slide material. But if you had a code to find out the longest line in the file, it takes a lot of effort, right? This is kind of complicated code. But then you can slowly refactor, and maybe I'll talk about this some other time, but you can actually refactor all the way down to something that's small or even smaller. And then if you're really crazy, you can write a one-line